everyone. This is Geometry, Chapter 11, Section 1, Surface Area of Prisms and Pyramids. So in Chapter 11, we're just going to do 3 sections. And first 2 sections are going to be surface area of a few different shapes. And then Section 3 will be getting into some volume. So here we're talking about 3-dimensional shapes. We've been talking about just 2 dimensions this whole time, like squares or rectangles or circles or triangles, you name it. Now we're going to talk about ones you would see and you could actually hold with your hands. So a polyhedron is the name of this, and it's a solid that is bounded by polygons. And there are going to be no curves. Fix my zoom here. No curves and no gaps, which are the rules that we also have for polygons in general. So here we see 3 examples of polyhedron and 3 examples that are not polyhedron. So over here in each of these are curved, curved, and curved. These rather are made up of each individual face is a triangle here, so they're made up of polygons. Each individual face is a hexagon or a pentagon, depending on the one. And we see a bunch of triangles here making up this crazy figure as well. So parts of a polyhedron, you have the faces. So the faces are polygons. And those are the polygons that make up the sides. So like in this one right here, each of these triangles is a face. And there's actually 8 faces on this one, and counting the ones that we can kind of see transparently through the back. An edge is a line segment formed by the intersection of 2 faces. So in this example here, we have this trapezoid's a face, and this rectangle is a face. One of the edges is right here, the line segment connecting the 2. And we also have vertex, which is a point where 3 or more edges meet. So very similar to what we had with polygons as far as edges and vertexes. So a vertex right here, 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 and just keeps going anywhere you see really a point. So let's look at these first 3 these 3 examples and say, hey, is this a polyhedron? And if it is, what are the number of faces, edges, and vertices? So in this first one, is it a polyhedron? The answer is yes. It's every side is made up of a polygon, and there's no curves or gaps at all. Well, how many faces are there? There's 6. You see this one on the front, one on the top, one on the back, one on the bottom, and on each side here, there's another 2. Edges, well, it's basically counting the line segments. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 of them. Now we have to figure out, well, how many vertices are there? So let's count those as well. So we got 1, 2, 3, 4, 5, 6, 7, 8, and that's all of them. So there's just 8 vertices. Let's go on to the second example here. Is this a polyhedron? The answer is no. And the reason for that is there's curves. It's made up of a circle, and a circle's on a polygon. It's still a 3-dimensional solid, but is not technically a polyhedron. And this last one, this is another one that is a polyhedron. Each face is a triangle, except for this one down at the bottom, that is a pentagon. So how many faces are there? Well, there's a pentagon at the bottom, and then all these triangles, which there's 2, 3, 4, and 5. Number of edges, once again, that's the line segments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then how many vertices? 1 at the top, 1, 2, 3, 4, 5 more on the bottom. So that makes a total of 6 vertices. So let's talk about the idea of what surface area is. So in order to do that, let's actually understand some more specific shapes just besides polyhedron. So a type of polyhedron is a prism, and a prism is, like I said, a polyhedron with two congruent faces. So over here we see a prism, and the two congruent faces are these triangles on the front and back. Now you might be saying, well, Mr. Cross, what about these rectangles on the sides and on the bottom? Well, because it's defined as two congruent faces, those cannot be it because that's three of them. So we can look at this as being the front and the back, and the rest as being the sides. So, and those faces are actually what we call the bases. So the bases are the congruent faces we're talking about. So you can call them faces or bases, and they're the same things. Now the lateral faces are every other face. So you have bases and faces here. Excuse me, bases and lateral faces. The bases are the congruent ones, so these triangles. The lateral ones are the sides, because side means lateral. So all of those rectangles we were talking about earlier. So even more specifically on prisms, we have right prisms and oblique prisms. So right prisms have the lateral faces that are rectangles. So the sides of right prisms have to be rectangles. So you can see here, for example, we have a hexagon. A hexagon is a face as the bases, and all the lateral faces are a bunch of rectangles. Here another one where the bases are triangles and the lateral faces are rectangles. Then we have oblique prisms. This is where the lateral faces, the sides, are parallelograms, but they're not perpendicular to the base, so they are not going to be rectangles. So they slant is a good way to think about it. So here we have our faces as these parallelograms, which would be fine, but we have the lateral faces are other non-rectangle parallelograms. Same thing here, bases are triangles, but these lateral faces, the sides, are parallelograms that are not rectangles, so they don't make right angles. For a right prism, the height of it's pretty simple. It's just the height of a lateral edge. For oblique prism, it has to be an altitude to the prism. So it has to be perpendicular to the face, going down and perpendicular to the other face as well. So sometimes you might also see it dashed inside like this. So surface area is going to be talking about the idea of the area of all of the faces added together. A good way to think about it would be saying, hey, how much area would be covered if you were to try and paint the outside of this figure? So if we had to cover all of the top, all of the bottom, all of this side, all of this side, all of the back, all of over here, and all of over here, all of those faces, how much would that take? So essentially, the idea is to add up each of these sides. If you find the area of this first side and add it up to the area of the next side, and so on and so forth, you'll find the surface area. But we also have some formulas that can help us kind of streamline the process a bit. So for a right prism, remember that's the one where these lateral faces or the sides are going to be rectangles. The surface area, SA for short, is 2 capital B plus P times H, where capital B is the area of a base, so one of those congruent faces. P is the perimeter of one of the bases, which are congruent to each other, so you find one base, you find the other. And H is the height. So let's take example 1 here. Example 1, we have a right prism. The bases are these two triangles. And so let's just take one of these triangles and draw it over here. That might make our life a little simpler. And we're told it's an equilateral triangle with each side being 6 centimeters. Well, if it's an equilateral triangle, that means each angle is also 60 degrees. Well, in order to find the area of a triangle, we know area is equal to 1/2 base times height. We have a base of 6, but we don't have a height. So in order to find that, I'm going to cut it right down the middle and make this angle that was 60 degrees on the top in half to 30 degrees. So this is 30 degrees, and that's 30 degrees over here. Very similar to what we had to do when we found the area of any regular polygon in Chapter 10, Section 6. So if this is a 30, 60, 90 triangle now, with those three angles, we know this over here, the hypotenuse is 6. We know the short leg is 3. So now we got to find the long leg. Well, a reminder to go from a short leg to long leg, we multiply by the square root 3, making the long leg, aka our height, 3 square root 3. So in order to find the area of this triangle, we take 1/2, the 6 is the base, and the height, 3 square root 3. And that ends up getting us an area for the base of approximately 15.6 square centimeters. So now, that's the capital B we needed. So we know capital B for our formula. I'm just going to write out our formula actually as well. Surface area is equal to 2 capital B plus P times H. The capital B is 15.6 square centimeters. We need the perimeter, and we still need the height. The height, that's going to be 17 centimeters here. It's the height of a lateral face. So we just need the perimeter of the base. Well, the bases have 3 congruent sides that are all 6 centimeters. We add those together, or take 6 multiplied by 3, and get 18 centimeters. So now we have enough information to plug this into our formula to solve. Surface area is equal to 2 times 15.6 plus 18 times 17. So if we put that onto our calculator and let it do the work for us, we end up getting the surface area to the nearest tenth to be 337.2 square centimeters. And remember, just like area, it's in square units. So surface area is no different than that. On to example 2. Example 2 ends up being a little bit simpler because we don't have to worry about finding the height of a triangle like we did on example 1, because the bases are just going to be other rectangles. On this problem, you could actually pick, scratch that, sorry, I was going to say you could pick any two sides to be faces, and you could pick this and this to be your bases, you could pick the top and the bottom to be your faces, you could pick the left and the right to be your bases, if you really want. I'm just going to do what we see as the front and the back personally. That's going to make my life, that's going to make it easier for me to visualize it, and hopefully it's easy for you to visualize it as well. So reminder, the formula for surface area of any right prism, whether there's triangles on the front or rectangles on the front, is going to be 2 times the area of the base plus the perimeter of the base times the height. So we need to find B. Well, in order to find capital B, we have to find the area of a base. Area of a rectangle is length times width, also can be thought of as base times height. Well, the sides of that are 10, and 12 is not this, 12 is this over here. We can see that because of the 12 over there. Rather, this length is 5. So length times width is going to be 10 times 5, giving us an area of the base to be 50 square centimeters. So area of the base is 50 square centimeters. Perimeter of a base, 10 plus 10 plus 5 plus 5. If we had 10, 10, 5, and 5, add up all 4 sides of the rectangle to find the perimeter of it, we end up getting 30 centimeters. And the height doesn't need to be found. It is just the other measure of 12 centimeters. So now let's plug this one in. And we'll get surface area is equal to 2 times 50 plus 30 times 12. We can let our calculator do all the work once we type it in. And the surface area ends up being 460 square centimeters. Continuing on for a couple more examples of this. We have another triangle here as the base. So a reminder that the formula for surface area is 2 times the area of the base plus perimeter times height. So we need the base, we need the perimeter, and we need the height. We do already know the perimeter. the area, the perimeter, we know the height to be 20 centimeters. The perimeter we can find, if this side's 10, it's congruent to this side, so it also has to be 10. So for perimeter of the base, 10, whoa, I'm not sure what happened there, my iPad glitched. We take 10 plus 10 plus 8. So we get the perimeter of the base to be 28 centimeters. So now we have to find the height of the triangle in order to find the area of that base. Because remember, area of a triangle is 1/2 base times height. So if I take that triangle over here, and make a better triangle, we know 10 centimeters, 10 centimeters, and 8 centimeters. So again, I'll draw an altitude in at a right angle, and it cuts this to 4 centimeters on just this portion. So because this is a right triangle, and we already have 2 sides, and we're just looking for the final side, let's call it x for now, we can use the Pythagorean Theorem, which says as long as you take the 2 legs, square them, add them together, it'll equal the hypotenuse squared. That's a squared plus b squared equals c squared. So for this, it can be 4 squared plus x squared, in either order for those two, is equal to 10 squared. 4 squared is 16, x squared is x squared, and 10 squared is 100. If we subtract 16 from both sides, we get x squared equals 84. Well, if we take the square root of that, it doesn't work out perfectly, but we can get an approximate to the nearest hundredth, and that approximate is 9.2. Now we can actually find the area of this triangle now. So the area of the triangle is going to be 1/2 the base of the triangle, 8, times the height of the triangle, 9.2, giving us an area of this triangle to the nearest tenth to be 36.8 square centimeters. So that's my area of the base. Finally, we have enough information to plug this into our surface area formula. 2 times the area of the base, 36.8, plus the perimeter times the height, 28 times 20. Let our calculator do all the work for us, and to the nearest tenth we find the surface area to be 633.6 square centimeters. On number 4, we're given another rectangular prism where the sides, or the bases, are rectangles. This time though, we're actually solving for one of the side lengths. We know the surface area is 392. Well, it'd be helpful again to write our surface area formula to be 2 times the area of the base plus the perimeter times the height. Now for this one, even though we made the base this side previously, in my opinion, it would be easiest to solve for this variable if we just call that our height. So for that, when we would need to know our base area as well as the perimeter of the base. And we would leave our height as x. So what we'll call the base then is this side, or this side. Actually, excuse me, not that second side, because that would still be involving the x. I misspoke there. So the area of this base would be 8 times 12, because it's length times width. Meaning the area of the base would be 96 square centimeters. In order to find the perimeter, you take 12 plus 12 plus 8 plus 8. Personally, I would rather take 12 plus 8 and get 20, 12 and 8 again, and get another 20. So that gives me 40. It's just easier for me to think about in my head that way. Otherwise, if you can add them all together, and you still get 40 regardless of how you add them. We'll plug in what we know into this formula and solve for what we don't, because we know the surface area is 392 square centimeters. Put that as surface area. 2 times the area of the base, 96, plus 40 times x. And now this just turns into any algebra problem where you start solving for x. So 392 equals, I'm just going to go ahead and do 2 times 96 and get 192 plus 40x. Subtract 192, end up getting 200 equals 40x. Well, to get x by itself, you divide by 40. And x ends up being 5 centimeters. So that was that missing length there. Continuing on, another shape that we'll learn about today is the pyramid. A pyramid is a polyhedron, once again, that three-dimensional figure with polygons of faces, in which the base is just any polygon. There's only going to be one base here compared to on right prisms and oblique prisms, where there were two bases that were congruent to each other. The lateral faces of a pyramid have to be triangles, though. So all of the sides have to be triangles. And they all have a common vertex. They all meet at one exact point. So right here, this is probably the normal pyramid you think of when you think of Egypt and whatnot, where the base is a rectangle or a square, more specifically at times. And the sides, the lateral faces, are these 4 triangles. It doesn't have to be 4 for it to be a pyramid, but that's what we most commonly think of. As a matter of fact, this one over here is also a pyramid, even though the base is a pentagon and the sides have, you've seen there's 5 triangles for the sides. So some things we'll need to know for this formula in order to actually use it are going to be the slant height, which instead of this capital L, I'm going to call it a cursive L. And that's the height of each triangle lateral face. So if you look at the triangle, the slant height, as it points out here, is going to be not the vertex to being perpendicular to the base, that's the height of the prism, or excuse me, the pyramid, but the slant height is the height of one of these individual triangles, going from the vertex to being perpendicular to the opposite side. And we can see that slant height in this one over here, and it's this dashed line. Next thing is the height, which is just the height of the actual pyramid going down to being perpendicular to the base. We see that over here as well with a blue dashed line. We see some more descriptors of vocab words here. Vertex, this is the point where they all meet. Lateral faces, those are each of the triangles that are the sides. An edge, which is just any of these line segments, including the ones around the bases. And the base, which is the polygon at the bottom. That is not a triangle. Or at least doesn't have to be a triangle, I should say. I actually lost my cursive L there for the slant height. Alright, so find the slant height of the pyramid if the height is 24 centimeters and the apothem is 18 centimeters. Well, let's talk about what we need to find the surface area of a regular pyramid. Regular pyramid is just going to mean that the base has all sides congruent, so it's equilateral, equiangular, as well as being convex, just like a regular polygon. So in order to do this, you find the area of the base, which we earlier called capital B. You take the number of sides of the base times the length of the side of the base times the slant height, and you divide that over 2. Another way to write it is the surface area is equal to the area of the base plus the perimeter, because perimeter is taking the number of sides times the length of a side. Take the perimeter of the base times the slant height and divide by 2. This helps it look a lot more similar to our previous formula for the right prisms. So now we know that the height of this pyramid is 24 centimeters. Unfortunately, we want to know the slant height, which is the height of this triangle. Well, how we can find the slant height, for example, you could start either at the area of the base, perimeter base, or slant height, starting at slant height on this problem, is you can see a right triangle made here where the hypotenuse is our slant height we want. So I'm just going to take this triangle and draw it out here for simplicity. And we're told the height is 24 centimeters. The apothem, which means the center of the polygon to being perpendicular to the opposite side, is 18. And we want our slant height, which actually I'm going to do the cursive L since we're going to be using that same variable in a moment for it. So in order to find the third side of a right triangle when we know the other two, we do the Pythagorean Theorem. 18 squared plus 24 squared equals x squared. 18 squared is 576. 24 squared, 18 squared is 324. 24 squared is 576. I mix those around. And that'll be equal to x squared. So we add those together, we end up getting 900 is equal to x squared. Well, now, in order to get x, we square root. And the square root of 900 is going to be 30. So that means our slant height is 30 centimeters. And that was the only thing we needed to find on this one, but we could find the area if we wanted to. Obviously, the surface area if we wanted to. If we wanted to find the surface area of this pyramid, we would need to then find the area of this base as well as the perimeter of the base, which we could find using this pentagon and going through the same process we did last chapter, where you have the apothem is 18 centimeters and making all these triangles and all that stuff that we did before. But we don't have to on this problem, so we're not going to on this problem. Continuing on to our next example, one of our last few. Find the area of just one lateral face. So a lateral face. And remember, the lateral face is one of the sides. So it wants us to find the area of one of these triangles. If I find the area of one, it's the same thing as any other. So we have here 12 as the height of this pyramid, and we're told that 6 is the length of this side. And I'm actually going to go ahead and give the information that the apothem is 3. So if we want the area of the lateral face, we need the base, which we have as 6. But we also need the height, which we also call slant height in a prism. So if I draw this right triangle out here again that I formed, the bottom's 3, the height is 12, and now we need to find this slant height. So in order to find that slant height, once again, we put it in the Pythagorean Theorem. Don't know again what happened to my iPad, same thing as earlier. 12 squared plus 3 squared in either order is equal to our lateral height squared. 12 squared is 144, 3 squared is 9, and our lateral height squared is just lateral height squared, or L squared. 144 plus 9 is 153. Square root both sides. End up getting the lateral height to be approximately to the nearest tenth, 12.4. So now in order to find the area of one of these lateral faces, we take 1/2 the base of the triangle, which is 6, times the height of the triangle, which we just found to be 12.4. Plugged it into our calculator, let it do the work, and we get the area of one of these lateral faces to be 37.2. All right, example 3, we're actually finding the surface area now. And I'm actually going to give another piece of information on this one, that the apothem, I'll actually draw it over here to the other side, make this another right angle, is 17.9 centimeters. So I'm going to write that up here, given that apothem is 17.9 centimeters. So, reminder, our formula is going to be that surface area is equal to the area of the base plus the perimeter of the base times the slant height divided by 2. We do not know the area of the base yet, that pentagon. We do not know the perimeter yet, but we can find it rather easily, knowing that one side is 26, and there's 5 sides by taking 5 times 26. If we do that, we have our perimeter as 130 centimeters. And we also need our slant height, which is given to us as 35 centimeters. So the only thing we need to find is the area of this base. So I'm going to draw out this pentagon, Slightly better than my pentagon earlier, but still not great. Let me try this again. Best one yet, still not great. So we're told an apothem is 17.9. Let me draw that in again here and zoom in. Third time's a charm, right? And one of the side lengths is 26. Well, just like previously, I'm going to cut triangles when we're finding the area of these polygons. That makes here to here 13 for half that bottom of the triangle, half the side length. And reminder, area of a regular polygon is 1/2 the apothem times the side length times the number of sides. We know the apothem is 17.9. We actually know the side length to be 26 already. And we know the number of sides to be 5. So we actually didn't need to draw that triangle, but it can be helpful to still draw this pentagon off the side so we can realize what we're dealing with. Now we're going to plug this in to find the area of a base. The area of the base is going to be 1/2 times 17.9 times 26 times 5. We put that all in, and the area of this base to the nearest tenth ends up being 1,163.5 square centimeters. So now we plug that in for our B. And we plug all three of these pieces of information, the capital B, the capital P, and the L, into our surface area formula. Surface area is equal to 1,163.5 plus 130 times 35 over 2. That ends up being 1,163.5 plus 2275, or you can let it all go in your calculator at once, as long as we're careful to have these both divided by 2. And the surface area to the nearest tenth ends up being 3,438.5 square centimeters. Now we're going to be on to our last sample. Oh, good thing to know my AirPods are at 20%. Finding the surface area of this regular pyramid. This time the base is a rectangle rather than, a square since it's regular, since all 4 sides then have to be congruent. And there's 4 lateral faces. So the surface area formula doesn't change. It's still the area of the base plus the perimeter of the base times the slant height over 2. We need to find the area of the base, we need to find the perimeter, and we are given the slant height to be 120 centimeters right here. Well, the perimeter of the base is just taking the number of sides, 1, 2, 3, 4, times one of the side lengths, 100, and we get 400 centimeters. Thankfully, the area of the base is going to be pretty simple to find as well, because the area of the base, area of any square, is just one side squared, or times itself. So that ends up being 10,000 square centimeters. So we have all of the pieces of our formula, so we just plug it in. Surface area is equal to 10,000 plus 400 times 120 over 2. Type this into our calculator and let it do the work for us, and we get the surface area to be 34,000 square centimeters. And that is all for section 1 of chapter 11.